23. In the xy plane, exactly how many x-intercepts does the graph of f of x equals x times quantity x minus 4 squared times quantity x minus 5 cubed have? Okay, so x, whenever I have an x, I know right away that's essentially equivalent to x minus 0, which means my root, or my x-intercept, is 0. So 0 is a root. Okay. X minus 4, well, that factor means plus 4 is a root. And in fact, this is a perfect square, so it's going to somehow be shaped where at plus 4 it touches the x-axis at 4, but then comes up again. The squared indicates it does not cross over or change sign. X minus 5 cubed indicates plus 5 is a root as well, 3 times over the same root. So for a cubed function, it will cross over, but that kind of indicates there's only one crossover there. In fact, that crossover is actually going to occur there, because x minus 5, the offset of minus 5 to x, indicates that we're shifting the same graph 5 to the right, all else equal. So it's probably over there at 5. So looks like at the end of the day here, I've got 3 roots that are real roots and x-intercepts. The correct answer for 23 is B. 24, the effect of a mineral supplement in the soil and the growth of particular species. In study, botanist plants 1,000 seeds in a greenhouse so that the growing conditions for all seeds will be as identical as possible. The seeds were obtained from 2 500 seed packages. Okay, so I've got 2 500 seed packages. All right, column 1 and 2. The seeds from one package were planted in soil that had the supplement added, so that went into the supplement added. And the seeds from the second package were planted in soil with no supplement, so that went into no supplement. Okay, so we're trying to study the effect of the supplement, but the problem is I could find a difference between these two, and that difference could be the result of the difference between packages 1 and 2, if they're somehow processed or packaged differently than the actual supplement itself. So that kind of messes up my entire experiment. We see these problems quite a bit. You have to apply some common sense and some reasoning to assess what is the right experimental design to get a randomized, correct output without being biased one way or another, or exposing it to possible flaws. So how should the experiment change? It should be changed here. Is it one of the packages of seeds should be planted outdoors or a greenhouse? No, there's no information. A lot of the answers give you answers that, they seem plausible, but there's no discussion of that in the actual question. So those are wrong. Half the seeds from each package should be randomly assigned to each soil type. That sounds good. That sounds right. To correct our issue or our bias for package 1 versus package 2, I could take half of 500, put them there, half of 500, put them there. The other package, I could put half in the supplement and half not in the supplement. And then I'd have an even mixture between the packages and essentially, or hopefully, no bias from the packages, and be focused only on the supplement versus no supplement growth. That would be the correct experimental design. Okay, all 1,000 seeds, well, I can't have all 1,000 seeds receive the supplement because that defeats the purpose of the experiment. I want to see what supplement versus no supplement is. No changes to the experiment. Well, as we discussed, changes are needed to the experiment. The correct answer for 24 is B. Researchers estimate 0.07% by mass of 12-gram sample consists of some fatty acid. Based on the estimate, what is the mass of that acid in grams in this orchid sample? Okay, so that means the percentage by mass of the acid times the grams of the sample, 12, will give us our answer. Notice a quick vertical scan shows all the answer choices are differentiated by factors of 10. So we need to get our factors of 10 absolutely correct, get our decimal places right, read percent versus non-percent accurately. All the answers are in decimal form, none are in percent. So 0.07% is not 0.07 times 12. 0.07% in decimal form is 0, 0. I need to add 2 zeros to make a percent a decimal. 0.7. That I multiply by 12. Well, one way to do decimal multiplication is just do 7 by 12, and that's 84. And then adjust my decimal places. So to do that, I'd adjust 1, 2, 3, 4 decimal places. So 84 becomes 1, 2, 3, 4 for my decimal. It becomes 0, 0, 84, 0.0084. The correct answer for 25 is A. And I was careful to differentiate percentage versus decimal and make sure I get the correct number of decimal places in the problem. That's the key to a question like this. 25 is A.